Hey guys, welcome back. So we have no time to waste today. We're going to jump right into it. I'm going to give us a little short review of where we were last week because this stuff is kind of linked together. If you remember, we're talking about that analogy of baking bread. So we're putting in the ingredients, we're running them through a process, and hopefully we get to the other side of a full loaf, if that analogy still makes sense. But today we're actually going to get to the baking process and the outcome, and ultimately what that means for us is how do we take this information and use it to make clinical decisions, okay? So we'll get to kind of we'll polish it off a little bit, and then next week we'll talk about reliability and validity. So like what kind of doubt can we have about the process? Because a lot of us have our doubts about what does this information mean? Is it valuable? Is it good quality stuff? And that's what we're going to talk about next week. So we're going to finish this part, add on a little bit more next week, and then we'll be done with the stats stuff, okay? So we're about halfway through. Okay, so just as a reminder, I'm going to scan through to show you a few of these slides just to jog our memory. We're not going to spend much time on them, but we go from this raw data that essentially is our experience of the world and the way things are, and it's kind of chaotic, and we can only take in as much as our eyes and our ears and all the rest of our senses allow us to, right? But if we keep data points on things that happen through time, for example, over years or between sessions or in greater space than we have access to. In other words, like, do people from California have the same experiences than people in New York? So we can kind of expand our own personal experience by collecting data from these other places through time and space to give us more context, okay? That's the important thing that this gives us the opportunity to do, is to expand our understanding beyond what our own personal experience is. And it gives us important checks and balances to make sure that it's not just our fallible experience that we're relying on, but other people's, and a scientific process that helps us sort of weed out error in our process. By the way, error is what we're going to talk about in next week when we get to like reliability and validity and stuff. So we talked about distributions, and then we talked about measures of central tendency. So you put it through the bread making process and you use the raw ingredients, flour and water and yeast and that kind of thing. Mix them in a bowl or run it through a statistical analysis, and you can get things like average. Measures of variability. So variance is the next step, then standard deviation. I'm actually going to walk you through that in class, or I have walked you through it in class already by this point. So you probably saw that in the book and were like, oh, good, we don't have to look at that. And then you got to class and you were like, oh, crap, we actually have to do this. Even though I told you we weren't gonna, we're not doing the math, of course, but so you saw how that worked and you saw the process, even if we don't need to know it in depth, right? And then the other one that's kind of important here was standard deviation. So we'll talk about standard deviations. I'll go through them a little bit right now in just a second, and then we'll explain how those fit in, and then we'll look at examples. That's going to be the big thing. We'll probably have done a little bit of that already in class, but that's going to be one of the things that we're going to pay attention to. In addition to that, though, the next part of this is, it's not on here, it's the next chapter. So let's go jump into that one. I'm actually going to get rid of this guy. And we'll jump into this one. And I'm not going to, I'm going to come back here and go to the slides, and I'll open this up and turn on the transcript and everything. But now today we're going to talk about percentiles and standard scores. That's really the big thing that we want to get to, because in all of the outputs that we're going to look at in class, the assessment results, that's what we're going to see is some version of percentiles. We need to understand standard deviations so we know how to read a normal curve. And then we're going to understand standard scores and the various different kinds of those standard scores too. So that's what today is going to be about, okay? So before we jump into this lecture, I'm going to pull up our book pages here. And I'm not going to walk through this because you just did this in class, but I'll remind us of this process here. So remember, as I've been talking about the ingredients for bread making, the statistical processes, this is essentially what it is. And just as a reminder, we don't care about knowing the math right now. That's for if you want to understand these assessments in a lot more detail, understand how to create them, how the math works, and all that kind of stuff. Some of you may want to do that, and it's probably important if you're going to be giving some of these. But this is something we're going to not spend as much time on because we want to focus on clinical application. That's the important thing, okay? At least for us at this time. But here is a raw score. In class, we have used this example. The 62 is the raw score, but we don't really know how that compares to other students. We can look at this and say, well, oh, geez. It looks lower, but how much lower? Is it a passing score? Is it a not passing score? We don't really know what that score means, right? So then we do we look at this notation. Last week, we also talked about this other terminology, the other language of statistics. If you didn't know that this capital italicized X, is that even italicized? I can't tell, but it's a capital X. Usually it isn't in notation, but it looks crooked to me. So we're going to say it isn't just because I don't think it's supposed to be. But anyway, with the line over it, X is any given score. X with a line over it means average. Okay, so you don't need to remember that. You might see it sometime, but not a big deal. And then you look at this math equation. This equation essentially means, probably really hard to see. This equation essentially means if you sum up, that's that little backwards E looking thing. If you sum up, or that's a forwards E, but you know what I mean. Sum all of the individual X scores, which is essentially all of these. So add them all together and then divide them by the number of scores. That's the N. That's average. So it looks weird. And if you've never seen this before, you're like, why do I have to do it a different way? Good question. I have no idea, but they do. That's what that means. So this line over the X means average. Here's the statistical notation, but it's the same calculation you've always done. Okay, so that's why when I say things like, you probably know this stuff and you probably understand it, but because it looks like it's a different language, you don't really think you know it, but you probably do. Okay, and I'm going to try and prove that to you with the rest of the stuff we're going to talk about today, that a lot of it is like, you can get this, it's just done in such a strange way because for various reasons, which we'll get to. So anyway, if you recall that part from class when we talked about that, and then this is a part that we're not going to talk about, but it's just an important part of the stats to make sure it's done correctly. So you take every individual score and subtract the average from it. I'm not going to go through this scribbly little thing, but remember that's a way to get variance. And then you square each individual difference. Just part of the math. Don't need to worry about it, but you see the process there. And then do some other stuff. You sum up the squared differences. And again, who cares? This is the important one. If you divide after you put it through this mill, in other words, take the flour, water, yeast, stir it around, mix it together, let it rise, knead it, proof it, knead it again. All of those individual steps are important for bread making. And you don't get the same result or don't get good bread if you don't do it. Same thing here. If you don't do this stuff, you don't get good results. So you just take it for granted that you have to do it if you want to learn how to make the bread or do the stats, right? And then you get this thing called variance. The variance is something we don't care about, but the standard deviation, this number is. You'll want to know what standard deviation is. And there's a question on the quiz coming up. I'll tell you that about this. Do you have to memorize it? No, but you will want to be able to come back and reference this stuff if you ever need to. So the idea with this class is you don't have to remember everything and cram it in your brain. You do have to know enough to pass the NCE exam, but you can always come back to this stuff if you have questions. Know your resources and know your references. Know how to learn, not know everything. Just know how to find it, know how to get to things. That's the important thing. You don't have to understand every ethical scenario in the world. You just have to know how to work through each of them or know the people that can help you and support you, right? So that's the idea here. Okay, so we have standard deviation. Okay, that's the number we're gonna talk about, or we did talk about in class. This other stuff, we'll probably spend some time on this in class, but also I don't really think we need to care about it quite as much. This is a question for the research stuff. But Pearson's R, if you remember the small italicized R, is related to, this way, that italicized R is related to correlations. So we're not going to spend a lot of time on that, but if you recall that R means correlation every time you go through it, numbers between 1 and -1, that's the stuff, okay? So we'll perhaps find some time for that, but I just wanted to show you those things just to give you a reminder. Okay, now that we are here, let me open this up and go back to where I want to actually stand to talk about these things. Okay. Okay, Ava, you got to move, dude. My dogs are laying on the floor again. I'll pick them up later. I had a special request to show more dogs, so we'll do that later. Just to kick their butts out of the way right now. Okay, so before we continue our discussion about getting to percentiles and explaining what those mean, I want to talk about a few other sort of random, as my British colleague that I used to have, not Ola, but a different one, she used to call it bits and bobs, just little bits and pieces here. So bits and bobs about this statistical information. When we talk about the normal curve, as we get into this, we're going to be talking about this second bullet point down here, the norm reference scores. There's another kind of test called criterion reference scores. Both of these are important, and both of these you will use. In fact, in class, when you did the BECS and the PHQ and the GAD-7 and some of those other diagnostic tools, you were using a criterion reference score. The difference between these two is a criterion reference score, and I'll try and follow the content here a little bit, is to use some standard of performance, some criterion or content domain or construct to interpret the results. Okay, so an example of this would be if you took the, let's see, if you took this final exam or the stats quiz, or you took a driving test, you're not being compared against other people. That's what this one is, and I'll get to this in a sec. You're not being compared against other people. You're being compared to how well you drive or how well you know the content of the class, or the criterion, which would be the diagnostic symptomology of depression, anxiety, or whatever. So criterion reference scores refer to things that have a sort of standard bit of information, and you're comparing people against the criterion of depression or the standard of education or driving or something like that, not against other people, okay? The norm reference scores, those are slightly different because you're comparing one person against another person. So for example, if you take a test and that test is graded on a curve, then you're comparing one person's score to the other ones, okay? That's the one we're gonna spend the most time on, but you'll have plenty of examples of criterion reference scores. When you're looking at an assessment, most of the time you're probably not going to think about these differences. Like, you're not going to say, I need a criterion reference test right now. You just don't do that. But you do need to know the difference between how the information is interpreted, whether it's against a criteria or against other people. Okay, so this will become a little bit clearer later as we look at examples. So I'm going to come back to this. I'm going to skip over these sub bullet points because I think you can kind of read those and probably pretty self-explanatory. The one thing I will talk about down here is about the norm groups and how norm groups are created. We referenced it in class last week. We probably talked, 2 weeks ago. We probably talked about it during class this week. By the way, it's Monday morning, so I'm doing this before Monday class and Wednesday class. So that's why I'm kind of skipping over my timeline here. But the issue with norming, as you might recall, is that when we set up a test or when we build an assessment tool, we have to find some standard of performance. In other words, that calculation we just looked at, we run people through examples like that because we have to find the average. And I'll skip back here really quick. Well, I'm not going to skip back because I want to keep the transcript up. But if you recall that normal curve, we have to be able to find the middlemost value, or the average, not the middlemost, but the average of them. If we don't have an average, we don't know how many people fit between the 1 standard deviation above and below, and 2 standard deviations, 3 and 4, etc. So we have to be able to figure out what are normal likely scores on this assessment, and we have to have data. In other words, people's input, people's scores. So when we're norming a test, we collect a bunch of sort of baseline information about where people are at, and then every subsequent person that takes the test, we can look back and say, oh, that person scored a 50 out of 100. Well, that's exactly average. Or let's say they scored 80 out of 100. That's exactly average. Or if they did better or worse, we can see where they fit in the continuum. Okay. So in other words, we have to have a baseline. The problem is that when we do create that baseline, if we don't get a good enough representative sample, we're not comparing people to the right people. So example, if you recall in class, I'm not sure exactly what example we'll talk about, but the idea is that, like, let's say I want to create an assessment tool, and I use you guys, all of you graduate students from the Midwest of a sort of middle age range, and I want to find out how well you do on I don't know, how well you can put blocks, shaped blocks into a shaped holes on. Remember those little things? Here's a baby. You put a square block in the square hole, a round block in the round hole. I want to see how well you guys do something like that. And I say, well, these graduate students, they're pretty good at putting blocks into a box with shapes, you know? So they all scored 90%. Let's pretend one of you just can't do it. You just brought the curve down, but let's say you scored 90% and all of the blocks went through the correct hole, okay? And then I took that test and I brought it down to, I don't know, Florida or up to Alaska. And I said, okay, I'm going to actually, test isn't really for graduate students. It's for these little babies, so these little toddlers that are trying to figure out the task of putting blocks in. And they're all really stupid because they can only do about half of them. They're just not very smart. Compared to those graduate students, these kids are idiots because they're toddlers and they don't get it. But the problem is that if I don't have that representative sample from the very beginning, then I'm not comparing toddlers to other toddlers. I'm comparing them to graduate students, and that really isn't fair. Now add on layers. If I run a test with European Americans and then start using it on African Americans or Mexican Americans or Latin American, whatever it is, Chinese Americans, then I'm going to get different results. And it doesn't mean that people are not smart or not capable or not sick or whatever the measure is. It just means I'm not comparing apples to apples, okay? So we have to have a representative sample in the test to make sure it's a fair assessment. And this is where our ethics come into play and where a lot of discussion about culture and diversity and that kind of thing can fit in here. Oh, my head's all cut off. Sorry. Here, I'll see if I can fix this just a little bit. So that's a question we can have in class. However, we have to know the science in order to be able to have that discussion. That's not something we're going to spend a ton of time on. However, if that's something that's concerning to you, it's better to know it and understand it and be able to explain why you're not using a test than it is to just say, like, well, these tests seem unfair. That's a thing that happens quite a bit, of like, they seem like they're unethical, shouldn't use them. I'm just going to trust other people who do it, who say either they're good or they're not good. And we're running into some scientific problems with people not understanding the science in our culture today. So really getting it and making making good valuative judgments about your tests, about your research, that kind of stuff, based on research that you know and understand, is important. And if you're not doing that, it doesn't mean that you can only read the headlines or just read the abstracts or make decisions about your life based on what you see online if you don't really understand the science. That's the tricky part here, okay? So that's why we're going through this kind of stuff. Okay. One other thing I want to explain to you is one of those issues, because it will come up on different tests, not just my test, but this comes up on things like the NCE. There's this thing called the Flynn effect, and you don't need to like memorize it, but it's just one example of a flaw. I'll just get myself out of the way so you can read this actually. The Flynn effect essentially says that scores can change over time. So here's an example. If I took an intelligence test, like some of the tests like the WAIS, by the way, we'll get to this later, but these are some names you'll want to know. The Wechsler Intelligence Scales. The WAIS is the WAIS, the Wechsler Adult Intelligence Scale. That's what it stands for. Or there's the WISC, Wechsler Intelligence Scale for Children. There's different examples of what those are. We'll get to them later. But if I took that intelligence test, which is still used today, it was used a long time ago. I'm not really sure when it was established. But let's just say it was from the 1920s. During the 1920s, the majority of people lived still on homesteads and farms in rural America. And there were more people moving to the urban centers of America, but they were kind of like factory jobs, right? Fast forward today, we now have a whole bunch of different information that we have to know in order to do our work, right? and the way that we live our lives. So, for example, we have iPhones and we have computers, and we have to know math and some technical details a lot more than we used to. Back in 1920, we had to know about things like how to farm, and we used our physical body a lot more to do work, factories, farms, that kind of stuff. Does that mean that people were less intelligent then than they are now, even though we're using our brains in a completely different way? Well, if you were to give the intelligence scale, like the weights, to people back in the 1920s and compare them to people today, they would look mentally handicapped. They would look like they have intellectual disabilities. Score very low on it, right? Which is why we can't compare people to people and why test scores need to be maintained and updated. So if you gave the test in 1920, you gave it to a whole bunch of people, and then you were, giving it to various folks, you'd be comparing people of the time against people of the time, and they would have average scores, and you could tell what a normal intelligence would be of that time. But what the Flynn effect says is it essentially says it looks like people are gaining intelligence over time, and yet there's something about that that just doesn't seem right. It seems like a different kind of intelligence, but not more intelligence. Or maybe it is. And that's where the theorists get to figure how to interpret these scores and what they actually mean. That's why tests like the WACE are what we call those level C tests, if you recall that from a couple of weeks ago. Level C tests are more complicated because you have to understand the foundational theory in order to interpret them correctly because of things like this. Okay? So that's why it requires a little bit more knowledge than just something like the GAD-7, which you have diagnostic information or you're getting it, you will get it, but we don't necessarily go deep into the theory of intelligence or personality or some of those other more complicated ones. Okay, so know about the Flynn effect, know about some of those biases that kind of find their way into assessment processes. And there's some more in your book too. I'm just sort of referencing the ones that I've seen on tests and things. So there's that. So now let's get back to our understanding of percentiles. And what I'm going to have to do for this is I'm going to have to show you some normal curves. We did this in class too, so I'll just kind of make a reminder of this. But depending on when you're watching this, you might see this before or after. So I'm going to try and cover it, even if it's review, but it's helpful to review, I think, in these cases. So percentiles, this is something that you have to know because this is essentially what you use the great majority of the time. If you've already been interpreting some tests, like if you're a school counselor and you've seen outputs on standardized tests for children, you've probably already run into this stuff. And so this might be kind of review, but we're going to do it more and more and more just to give you a good idea of how this stuff works. Okay. Essentially what this is it gives you, if you were to line up 100 people in a row and you said this person is at the 50th percentile, you're essentially saying that that person is at spot 50. That means 50% of people score below them and 50% score above them. Okay. Another example, if this percentile is the 75th percentile, you line up 100 people, you put them at 75, that means 74 people score below them and 25 score above them. Okay. So you can always think of that picture in your head. If I put these people in a row, some would score below, some would score above. Okay, it's just all about that placement in a scale of 0 to 100. That's not only something for you to think about what these scores mean, but it's a very helpful way to talk to parents and clients about what a percentile is and how to understand it. It's simple, it's effective. People understand it when you talk about lineups, but in terms of the math is harder to understand. Okay, so we'll come back to that over and over again. The one thing to know is that I'm not going to spend a lot of time on this because I don't want to confuse us too much, but there's a difference between a percentage and a percentile. Okay, people will make that mistake. If we come into an example in class or something, we'll talk about it. But it can get kind of confusing. But I want to keep it simple for now so that we understand as clearly as we can about the differences or what we're really trying to get to here, the essence of the information without getting lost in details. Okay. There is a difference, but we'll talk about it later, if we talk about it at all. The standard scores, now this is where I'm going to skip to a picture in just a second. Standard scores are just different ways of understanding basically the same information. So when we took our flour and water and yeast. We mix it in a bowl, then we knead it, proof it, knead it again, do all that kind of stuff. We're putting it through a chemical process, or in our case, a mathematical process, and we're changing the fundamental foundation of that information. However, standard scores, we're not changing the fundamental information. For example, with the bread, what we're doing is we might just knead it into a ball. We might knead it flat. We might put it in a loaf pan. All we're doing is essentially changing the shape, but it's the same bread. Same thing here. It's the same information. We're just putting it on a different scale. So here's an example. I'll show you. Let me sit down on my stool here, actually. Now I got to move my camera. Maybe I'll just sit here for the rest of the day. I don't know. So if I pull up our, let's use the other one actually from our book. Oh, no, I can't do that. We're using this other one. Well, I don't like either of these, actually. Where's the good one? Here's our book pages. There we go. If I have this scale, right here, we have our normal curve and we have percentiles, okay? If I look at this scale and I see a percentile, I can kind of glean some information, and we'll talk about that information in just a minute, but I want to stick on standard scores here. I can glean this information about what that score means, not just in terms of the lineup, what I said earlier, but in terms of how I understand where this person fits and what that number means. Okay, so we talked about it in class, so hopefully that makes a little bit of sense. What standard scores are is if I look at a chart like this and I see on an assessment output, I see a percentile and a T-score. These are really common ones. And I see, let's just say, I don't know, one of these other ones, stay 9 scores. If I see those three things, essentially what they mean is the same information in reference to the normal curve. In other words, how I compare people to other people. It's essentially they have the same place in the lineup per se, but the score looks a little bit different. So percentiles, this is going to get in the weeds here, so I'm going to slow down and we're going to see examples, and this will make sense in a few minutes. But percentiles, you can see the 0 is like, or there's never really a 0, but the percentile is a lot closer to this 2 standard deviations below. That's what that -2 means. And 99 is like a ways above that. A T-score, though, sorry, I'm trying to flip back and forth between these things in a way that actually makes sense. T-scores, the scale looks a little bit different, but we're still talking about a 0 to 100, okay? So we just change the information to look a little bit different. If I want to know a percentile, the 50th percentile, and I just run my finger or my mouse, whatever, hopefully you can see that well enough, down to this number, 50, a T-score is on a scale of 0 to 100, and so is a percentile, but they mean slightly different things. If I'm trying to find an IQ score and I want to find the average of this scale is, an IQ score is always going to be 100. Okay, and that's just a fact that you'll have to memorize. But we'll go over some more of that in a little bit, and we'll bring all this stuff together, because this is when it really starts to get a little bit confusing. If I see on an assessment output a stay 9 score of 5, that means I can know, because I know what that standard score means, or when you get comfortable knowing what they mean. If you see a number 5, you know that means average. Stay 9 actually means standard 9, so it's numbers between 1 and 9. Other times, other tests are developed with a STEN score or standard 10 score, so it's between the scale of 0 and 10. So hopefully you're seeing what I'm doing is I'm just changing the scales or the standards of what is this number between 0 and 10, 0 and 9, 0 and 50, 0 and 100, that kind of thing. It just gives you a different way to look at the information, kind of like when we were talking about histograms and frequency polygons. Sorry, stumbling my words. Line graphs and bar graphs. It's just different ways of seeing the same information. That's all this is. So when you look at these test outputs, if you recall this kind of chart and you can understand that a lot of those numbers mean the same exact thing, then you're going to be able to interpret a lot of stuff. Okay. So I'll go back to an example and we'll cover some in class, but this is what you'll come into contact with these kind of things quite a bit, and you'll be able to tell what those numbers mean. Okay. So let me go see if there's a good example I can show you that's already on this output. Oh, in class, we'll talk about several of these different scales. This is an actual output from a test. I know it looks really crappy, and I'm sorry, just bad copy job. But this is the actual output of a test, and we'll go, either we did it last week or we'll do it next week. But on here, what you see, for our purposes right now, is you see this standard score, percentile, NCE, Stay9, all of these different things. So this whole bottom row, it's all the same information. It's just a different scale, and it looks a little differently. If you are somebody who really understands percentiles because you can talk about them and explain them to people, in most cases, you don't need to pay attention to the rest of this. There are some kinds of standard scores like Stay9s and STEN scores. Those show up almost exclusively in educational settings. I don't think I've ever seen a STEN score or Stay9 score outside of that in a way that really helps me understand. I do see them from time to time, but they're just not that useful. But you'll see a lot of those in educational settings. Why? I don't really know. I don't know if it really changes if it means something mathematically or statistically, or if it's just that people get comfortable using those numbers and they make sense. And so they use the ones that make the most sense given what the data is. So essentially, just to repeat myself, all of this means the same thing. This is just a regular old normal curve up here. So if you know what normal curves are, and by now we've kind of gone through some of them, all of these spaces mean the same thing. So we would have done that in class last week, or I'll go through another example of that here. So, and then down on the bottom here, these are just words instead of numbers. So you can kind of use this for writing up reports and things. When we get to the unit on communicating assessment results, people understand words better than they understand numbers. And so if you have this person, like for example, it's hard to see, but this line right here in the middle, this is that person's actual score on this test, which we can see down here, wherever it is. Oh yes, standard score right here. So this 109 is, oh no, sorry, not that line. It's these dots. It's hard to see these dots right here on the screen, but these dots are the person's score. They scored 109. That's their standard score, which is written down here in a table. Skip this circled thing about confidence intervals, and then we look at percentile. The percentile, if you look down this row, we have the number. Can't really see it that well, but visually we know that's like 74 or whatever. Down here we can look and say, oh, it's 73. Okay, that makes sense. So what's in the table here is reflected up here. And you notice they're all right on top of each other. And that's intentional because all of these are the same thing. It just depends on, do we use the number 109? Well, most people don't know what scale this test is. Which one is this, by the way? Oh yeah, the Peabody Picture Vocabulary Test. Most people don't know how many questions it's out of or what 109 actually means out of 160 or whatever that is, 180. But they do understand 0 to 100. So we translate that 109 into a number that makes sense to people a little bit more, which is 73. Again, just to reiterate, a percentile of 73 means 72 people scored lower. And I'm not going to do the math right now. Yikes. 26 people scored higher, something like that. NCE, I always forget that. I've looked up what that number means like a million times. I think it's like right in here somewhere. Oh, right there. Something equivalence. I do this every time. Normal curve equivalence. I never remember it, partly because I don't think it matters that much, but I've never seen this in, I don't see it in a lot of places. So I just kind of skip over that one, and you can too, unless you start using a test that uses that one. Stay9 scores, remember those are standard 9s, and so this score is a Stay9 of 6. We can see that down here, behind my head, sorry. And then it falls on 6 in the scale here, right? That's number 6, it's hard to see. If I'm writing this up on a report or talking to parents, whenever my son gets a test home from school, I don't know what those tests are. I don't know how they work exactly, but I look at these things. Oh, he's in the average range, just a little bit over average. Great, that's fine. Some parents like see a number like 4 and they're like, oh my gosh, 4, what's the average? Oh, it's 5.5. So 4, that seems not good because it's like a whole point lower. Is that really bad? And you look at this and you're like, no, it's not that low at all. He's like right in average here, within one standard deviation of the total, or sorry, of the average. So that's not a bad score. Can he work at doing things a little bit more, like reading better or doing math better? Sure, but it's not a score that needs intervention. This is where we start getting into clinical decision making of, should we worry about this? Should we not worry about this? Okay. So we're getting a lot closer to being able to use this information, even though I don't know what the Peabody score is. I don't know what, the Peabody vocabulary test. Do I need to worry about its vocabulary? I would argue no. On this scale, if it was a 4, I would say no. As average, pay attention to it. Let's do some reading at home, but we don't need special services, right? And that's the kind of decisions that you guys will look at and make for yourselves, or at least help make. Okay, so there's that. Let's go back to our PowerPoint. Which one are we on here? There we go. This guy. Okay, so we've just talked about percentiles and standard scores and showed you what those mean. Again, this might be review depending on what we cover in class. There are a few other things to know. When I showed you that the standard scores that were all kind of lined up on top of each other, I didn't talk about all of them. We did talk about percentiles. We'll go over t-scores when we go do examples. We may have already done that in class. One thing to know about deviation IQ, or when we think of things like IQ scores, we'll talk a little bit more about what those mean as we go through these units and in future units about intelligence tests. But sometimes people abbreviate deviation IQ as just div IQ. So you might see the term div IQ, or you might just see IQ. And IQ stands for intelligence quotient, okay? So if you see intelligence quotient, IQ, div IQ, deviation IQ, it all means the same exact thing. Again, this is just the lexicon of statistics. STAY-9s and STEN scores, I already kind of explained those. Also, it's worth noting that the SAT and the GRE, they have their own standard scores. So if you took, I never took the SAT, I took the ACT when I was in school, and I don't even know what the averages are, but I remember it being, I thought it was like somewhere around 20 or 21 or something like that. I don't even remember, but they have their own scale. If you took the test and you scored 27 or 5 or whatever you did, you could get the information about what is average, what's a good score, what's a get into a college score, that kind of stuff. And that's just a different scale. Probably some of us are familiar with that. Same thing with the SAT. If you got a score of, I don't even know what the scales are for that, like 300 or something like that. If you got that score, it means something different. It's just another way of seeing information and how you compare to other people. Okay. So our NCE test probably has a normal curve somewhere because the scale changes or the passing score changes, because all the tests that you guys take get inputted into a database. They recalculate what is average and what is passable, and then they compare future students against that. So just a normal part of the scientific process. Okay, so that's that part. Let's add another layer to this. Another thing that we'll see on clinical assessments is grade equivalence and age equivalence. And I have them here together because the way we interpret them is virtually the same. They just mean something slightly different, okay? This will be relevant to both school counselors and mental health counselors who are watching this. So what a grade equivalent is, let's just take an example here. I'll come back to this. Well, I'll just read you this. Grade equivalents are intended to represent a student's test performance in terms of the grade level at which the average student's performance matches that of the examinee. What the heck does that even mean? It's hard to understand what these things actually mean, so we'll come back to this definition in a second once we understand what the number means, because this is where we can get kind of tripped up, and if we don't understand how to understand this, geez, how to understand that exact quote, then it's going to be hard to interpret these things. Okay, so we'll practice a few of these. Mostly we'll practice them in class. I'm not going to practice them today. 11.4 is something common that you'll see for grade equivalence. Essentially what that means is this person is scoring the same as the average person who's in their 11th year in the 4th month. So what is the 4th month? If schools start in, let's say, September, so the first month would be September, October, November, December. So this essentially means 11.4 is an 11th grader who's halfway through their school year, September, October, November, December. 11.4 is halfway through that, halfway close to senior year, okay? So most people have a pretty easy time understanding what 11.4 means, but let's take an example here. If I were an 11th grader and it was December and I was taking a standardized test and I scored an 11 on that, I might say, great, I am in 11th grade and I'm scoring an 11. That means I score like an 11th grader would, but it puts me a little bit behind. It means I'm like 4 months behind in the content compared to the average person. So if the average person is scoring like they're halfway through their junior year, I'm scoring like I just started my junior year. Okay, we'll talk about some more examples in class, and we'll see some more things like that, and we'll interpret those because it's a little bit hard to wrap our heads around how this actually works. And we'll do some more, but let's go back to our quote here. It's intended to represent a student's test performance in terms of grade level, 11, 4th month, at which the average student's performance. So the average student, if we look at that normal curve, right in the middle is 11.4 because half the people are above, half the people are below. Average is whatever number that is, however they're scoring. And then we can compare how many months ahead or behind is that person, okay? So, which is the examinee. The average student's performance compared to or matches that of the person that's taking the test, okay? So that's what that means. Great age equivalents essentially work the exact same way. This person scored as if they were 6 years old in the 9th month, okay? Slightly different in the sense that they're 6 years old and 9 months past their birthday. So in terms of grade equivalence, pretty much everybody starts in September and goes to May-ish, at least close to that. So it's close enough that we can still rely on that number. But age equivalents are, I'm 6 years old and I've lived 9 months past my birthday. Our birthdays are all different. And so where we score in this is a little different compared to other people, but it essentially means the same thing. So let's say I'm in class and it's December and I've gone through half of my schooling and I get an age equivalent of 11.4. I'm a junior person. I'm like halfway through school. That's the average number and I scored an 11. In that case, it meant I'm 4 months behind. But somebody who also scored an 11, there might be 2 people. My score might be, and it's going to be different here, but I'm just going to use this number since it's here. My score might be 6.9, but their score might be 6.1. In other words, we score the exact same thing on our test and we're in the same year. We understand the same content, but their birthday is sooner or later than mine. And so I look like I'm 6 years old and scoring the average as a person who's got 6.1. But I might also score a little differently at 6.9 depending on when our birthday is, okay? That's a little bit of a brain buster and a little tricky, but once you see it in an actual example, it'll make a little bit of sense, okay? So if you know how to do 11.4, 11th grade, 4th month, and you know how to do 6 years old, 9 months past birthday, you have enough to help make that interpretation. The practice will be, what does that information mean and how do you communicate it? So that's what we'll get some practice doing after this. Okay, we're almost done here. And then I'll go through just a couple examples that we'll go through in class and we'll talk about them next week as well. So we'll wrap all this up together once you get some practice with these things. This qualitative scores, essentially what this refers to is the same thing we just looked at in the Peabody example, which is um, basically the words that describe what the numbers mean. And most scales should have something like this. When we go through the PHQ and the GAD-7, if you look at a number on the PHQ and it says, I'm just going to make up an example, this isn't accurate, but if it says the number 12 and that means moderate depression likely, does that mean a person has moderate depression? Well, kind of, but there's no diagnosis that actually is moderate depression, but that's the output of the scale based on the number. It's just giving us some language to compare what that number sort of means in context of the test. Then we have to do something to turn it into a diagnosis, which again is practiced later. We'll go through that later. So if we take the GAD-7 number or the PHQ and it gives us a number, we understand what that means in terms of standard scores, and we understand how to communicate that to other people. In the case of the PHQ, we don't really usually have to go through some of that more complicated stuff. People just want to know, do I have depression or not? Is it a diagnosis that we can rely on? Well, now we have some numbers that say you score 12. This says moderate depression. When we look at the DSM, then we can say, how does that actually show up in this person's life and how intense and frequent are these experiences they're having? Excuse me. What this qualitative scores means is it just gives us some language to talk about. When we do our final papers or the assignment from last week that we practiced in class, you can write the score to show what the number was, and then you can write moderate depression or mild depression, whatever it is, and give that language, because that's the stuff that other people will read and understand a little bit better, okay? The confusing part is that if you say moderate depression or mild depression, people are like, so do I have it or do I not have it? And that's where our clinical judgment comes in, of why we need to understand how to interpret these things so that we can tell people, you have it, but it's not clinically significant. Like mild depression doesn't mean you're diagnosable. It might, but it might not also. That's the tricky part here. So we need a little more practice with doing that, but if we've followed along so far, and you have some of this information, depending on what we've covered in class and what we will cover in class this next week and in the weeks following when we go through some of these different tests. By the end of this class, you should be able to look at an output score from one of these tests, make some interpretations about it, understand both the quantitative and qualitative information you see on an output report, and be able to make some interpretations about that. Now, if you recall from the very beginning of the semester when I said we're not going to go through every test, it's impossible to do that, but you should have the foundations enough to look at an output report, write a report, or put this in your clinical case notes, or communicate it to a client or patient or a student or something like that, parents. You should be able to do that, and we're getting so close to being able to do that with this information that we have here, okay? We're close because we have some of this background scientific information that we can translate into something that people can consume and use. That's the whole point of why we're doing all this, is to make clinical decisions and help people understand, what does this actually mean? So we haven't had a ton of discussion about this so far, but all of the TikTok therapists and life coaches and all that kind of stuff who are coming up with what do these experiences of life actually mean? Well, this is a different kind, another kind of information. Doesn't mean that we're discrediting all of those people and the way we understand mental health and mental illness, but it does mean knowing this provides you with something unique that not everybody is trained in and not everybody understands. So when you take this information, you compare it to the way other people who are less trained and have less understanding of the science, if you compare it, it can give you something to use in terms of like, well, is this actually OCD, or are you just being OCD right now? Do you know what I mean? Like, well, let's use a test to find out, does this fit the way that other people in other places and other times, not just through the lens of one person's TikTok experience, but through clinical trial and research and science over many, many applications of the tests that we use. Let's see if it fits most people over in most places. That's why we have science, and that's why we rely on assessments. If we don't rely on them, again, to make this argument, we're probably missing something or throwing baby out with bathwater. Okay, so hopefully I'm making the case effectively enough of why the scientific parts of this assessment are really important, and how we also have to use this and use our primary tool for doing humanistic, wellness-based counseling with other people and saying, tell me your story, tell me your experience. I will think about these other things, the clinical diagnoses, the scientific relevance or efficacy of illnesses or treatments or whatever. Think about all that stuff, and that's my experience that I can share with you, but I want to hear your story. And then I can provide clinical interventions in language that translates all that stuff into what we can talk about in our sessions. That's the goal here, okay? Other people can do that. Coaches, people trained at the bachelor's level who don't have all this background, they can talk about somebody's experience and do really good supporting and that kind of stuff. But this is a different level of understanding, which is why we have special training to do this, okay? So hopefully I'm making that argument well enough, and it's sort of making sense to you about the kinds of things you can be confident about, the special knowledge that you have, and the way that you can apply it in a way that shows others this is expertise that they don't have that's helpful to them. It's not just about showing them how cool you are and how smart you are. It's about giving them something else that they can use. That's the important thing. Is it helpful? Is it necessary? If it isn't, then I ask the question to myself, why are we even doing this? However, let's have this discussion throughout the class of, is this useful and in what ways? You may not know that, that's why I'm trying to talk about it, but the more you start to have those realizations, let's bring those up and say like, oh, okay, now I'm kind of getting something new here. All right, we're done a little bit early today. Let me see, I'm just gonna scan through this to make sure. We will have gone through some of these oh, that's so gross looking. Sorry, guys. We will have gone through examples like this, hopefully a little bit more clear in class. So when you read through these things in the book, we'll understand that stuff, and things like this key math. It's where we see things like grade equivalence and age equivalence and that kind of thing. So I'm not going to go through it now. We'll do that. Either we'll have done it last week in class, or we'll do it next week in class to really round out this part of our stats mini lecture or whatever. So one last thing for you is these. I'm actually going to open this up so I have my subtitles. One last thing for you is when you're thinking about coming to class, one of the things that's normal for people at this stage is like, okay, I'm hearing all this, and I'm also reacting to my own stuff. In other words, if it's confusing, it's normal to cope with our confusion by getting frustrated, wanting to give up, which is just a flight withdrawal response, or you get frustrated, which is a fight response. We're activating our nervous system. So if you're getting frustrated or wanting to give up, those are the points of confusion where you might want to ask some questions, okay? So at what point did you get frustrated, or what point did you want to give up? That can be an indication of what things are still confusing to us. So bring those questions to class and tell me where along this process do things not make sense. And so that's one tip. The second tip is that you may not know what you're not sure of, because at this point you're like, okay, I heard all that stuff and it makes sense, but I don't know what to do with this information. Once we go through some examples in class, that's where you might say, do I feel comfortable enough to be able to do these things myself, understand the scores, interpret them, and then communicate that to somebody else? You may still be confused by the end of this. And if you are, that doesn't mean you're not asking enough questions. It doesn't mean you don't know the answers, but we're going to go through more of this practice. By the end of the class, we should be a little bit more confident with these things. But again, this is going to take practice beyond the class too. So what I look for you guys to do is give me an impression when we get to classes about where you are with your level of understanding, excitement, interest, frustration, irritation, wanting to just give up or move on beyond all this stuff, whatever. All of those are okay responses, but it does give us good information about what to do about them, okay? So I think that's good enough for today. I will see you guys very soon. Bye-bye.